So my name is Olalekun, and my colleagues used to call me Maths Major by name. So the topic we are going to treat today is trigonometry. Trigonometry. So trigonometry, from the word trigonometry, you can derive a definition from it. This tri means 3, and this gono means sides, and metry means measure. So we can simply refer trigonometry to the 3 sides measure. That is, there is this shape that has 3 sides. There is this shape that has 3 sides, and the shape is called triangle. The shape is called triangle. We have different type of triangle. We have right angle triangle. We have isosceles triangle. We have reflex triangle, obtuse. Then every angle in a triangle add up to 180 degree. Every angle in a triangle add up to 180 degree. Now, aside that, we can derive an application from trigonometry, even from the fact that it's a triangle. We can consider it as the strongest shape in mathematics. It's the strongest. It can stand alone on its own. It can stand alone on its own. If you look at the construction of bridges, they make use of triangle. In the building, concrete buildings, they make use of triangle, because while sitting on a bench, if you are sitting on a bench, you will see a planks or log of wood. They will use it to bridge it at the middle. That means that they want it to hold firmly to the ground. So that's what they consider triangle to be. So a triangle in general, all triangle possesses the shape and size. The shape of a triangle is governed by 3 angles, which always add up to 180 degree. Like I told you, we have right angle triangle, we have different type of triangle. We have isosceles, we have equilateral. Equilateral, all sides are equal, all angles are equal, and each of them are 60 degree. While isosceles triangle, base angle are equal, 2 sides are also equal. Now let's look at a right angle triangle in general. Now, from this, we can generate the angle identities from this right angle triangle. We have something we call trig ratio. That is, we refer to it as SOH CAH TOA. Popularly, we refer to it as SOH CAH TOA. This SO means sine theta equal to ordinate over hypotenuse. Ordinate over hypotenuse. Now, we consider ordinate on the graph as y-axis, which is also known as opposite. So another name for opposite is ordinate. In mathematics, we make use of ordinate. So this side is called ordinate. So that means it is equal to line AB over line what? AC. The angle facing the right angle triangle, the side facing the 90 degree is called the hypotenuse, and it's always the longest side. Okay? So hope you are following. Now we have cosine, that is the curve from here. We have cosine theta equal to abscissa over hypotenuse. Abscissa over hypotenuse. This abscissa on a graph is usually considered as the what? As the x-axis. In some cases, they call it adjacent, but in mathematics, we make use of abscissa. Abscissa over hypotenuse. So the abscissa here is line BC over line AC. So that's it. Then we move to tan theta, which is the tangent. The tangent angle tan theta is equal to ordinate over abscissa, which is line what? Line AB over line BC. So these are the trig ratio in trigonometry. Now, apart from this, we can generate so many identities in which we are going to consider. We are going to make a lot of proof, and for being a math student, it's very important for you to know all these proofs. At least it's not less than 20. You must know it all. So you are done with this, right? And don't forget that tan theta is the same thing as sine theta over cos theta. That is, if you take the reciprocal of cos theta, then you divide. Then if you take the reciprocal of cos theta, then you multiply it by sine theta, you are going to get this. What am I saying? Sine theta is what? Ordinate over what? Over hypotenuse, right? Now, I said you are going to take the reciprocal of this. What will be the reciprocal of cos theta? Hypotenuse over abscissa. I said you are going to multiply, don't forget. You multiply by the reciprocal, which is hypotenuse over abscissa. That means hypotenuse, we cancel out hypotenuse here. Then you are left with what? Ordinate over abscissa. Hope you all get that. You all get it. It's not clear. You don't get it. This is what I'm saying. That is, if you take the ratio of sine theta to cos theta, that is sine theta divided by cos theta. Sine theta divided by cos theta is still the same thing as, you know, if I put division sign here, that means I'm going to change all of this to abscissa over what? Over hypotenuse. Right? Now, this division sign, when it turns to multiplication sign, then anything behind it, we turn to what? We reciprocate. That is, you are going to take the reciprocal of it. Now, if you want to change this division sign to multiplication, that means hypotenuse will come up and abscissa will go down. Are you getting it? So once it goes up, this one will turn to hypotenuse and this one will turn to abscissa. Then hypotenuse will cancel out. Then you are left with what? Ordinate over abscissa, which is the same thing as what? Tan theta. Do you get it? Yeah? Okay. Let's move to special triangles. Special triangles. Special triangles. Special triangle. Now, two right-angled triangles are of special interest because the trigonometric ratio of the angle can be given in surd. Okay, two right-angled triangles. Two right-angled triangle are of special interest. Because the trigonometric ratio, that is all these trigonometric ratios we did here, all the trigonometric ratios of their angles, all the trigonometric ratio of their angle of their angles can be given in surd or fractional form. Do you get it? Okay. Let's do some proofs of this special triangle. Now, the meaning of surd form is that you can have them as root 2, you can have them as square root of 3 over 2, you can have it as 1 over root 2. So these are surd. Then you can have them as fractional form. 1 over 2, 3 over 2, 2 over 3. Those are fractions, right? So let's attend to this. So given a triangle, 45 degree, then we have the angle here. This one is 1 and this one is 1. Now, if you consider this triangle, if you look at it very well, this triangle form a square, yes or no? Now, these are the method for you to find either hypotenuse or the long or the diagonal line of a square. Now, look at it. There are so many ways of killing a rat. In mathematics, you can derive an answer once your steps are correct and you divide it. Okay? Now, we can consider this triangle by finding the hypotenuse, right? Using Pythagorean identity. Hypotenuse square equals to opposite square plus adjacent square. But if you are to consider it using a square, that means you are going to find the length of diagonal. I'm going to show you the two. We are still going to arrive at the same answer. Now, if you are to consider this triangle alone, to find the hypotenuse, you make use of hypotenuse squared equals to opposite square plus adjacent square, right? Now, hypotenuse square equal to opposite, which is 1 square, plus adjacent is what? 1 square. So hypotenuse is equals to what? Square root of 1 plus 1. Hypotenuse is equals to what? Root 2, right? So this side is what? Root 2. But if you want to consider it in form of what? A square. Since this side is equals to this side, definitely this side is equals to this side. And this side is also equals to this side from line of symmetry. Hope you are getting it. Now, if you want to find the length of diagonal of a square, the formula is given as length of diagonal is equals to s root 2. Is equals to s root 2. This s here, given s to be what? S to be side of the square. So that's the meaning. So what's the length of the square from the side? Is what? 1. So definitely if you put 1 here, that will be 1 times what? Root 2. We are getting root 2 to be length of the diagonal. Do you get it now? So even if you are doing an exam and you are asked to find the hypotenuse, you can easily draw a square. Then you find the length of diagonal. You know that your answer will be unique, right? So if you are doing an exam, then you go by this approach. Then the marker will see that, oh, this person knows what he's doing. Do you get it? Now, I said we are going to consider... Okay, let's continue. Now, I said we are going to look for the special triangle, right? The angle of a special triangle. Now, 45 degree. If you are to consider 45 degree, sine 45 degree, cos 45 degree, and tan 45 degree. From here now, from the trigonometry identity I gave to you, the trig ratio, what is sine theta? What is sine theta from what I gave to you? Ordinate over hypotenuse. Now, from here, where is the ordinate? This is the ordinate, and this is the what? Hypotenuse. Are you getting it? So that's what? 1. Sorry. So that gives 1 over what? Root 2. So that's sine 45 degree. Then the second part is what? The second one will be cos theta is what? Adjacent over hypotenuse. This is the adjacent, right? And this is the hypotenuse. So you have 1 over root 2. Now, for tan 45 degree, I told you that tan 45 degree is the same thing as sine 45 degree over cos 45 degree, right? And I told you that once you make sine 45 degree, then you are going to multiply by the reciprocal of what? Cos 45 degree. So it means sine 45 degree times the reciprocal of cos 45 degree. It's still the same thing, right? Now, sine 45 degree from here is 1 over root 2 times the reciprocal of cos 45 degree will be what? Will be root 2 over 1. So root 2 we cancel root 2. Then you are left with what? 1. So tan 45 degree is what? 1. Are you getting it? So sine 45 degrees 1 over root 2, cos 45 degrees 1 over root 2, tan 45 degree is 1. You are done with this, right? This part. Now, let's consider an equilateral triangle. An equilateral triangle. Equilateral triangle, all sides are equal. Once all sides are equal, the angle, each angle in that triangle are also what? Equal. And since the sum of angle in a triangle is equal to 180 degree, then since all the angle in a triangle is 180 degree, add up to 180 degree. And once the angles are equal, that means you are dividing 180 degree by what? By 3. You are dividing it by 3, which gives what? 60 degree each. 60 degree, 60 degree, 60 degree. Now, from here, you can bisect the angle. That is, bisect means to divide into half. So, if you are to consider this part, I'm coming. This one is 2, this one is 2, and this side is also 2. So, if you bisect, you have another triangle. You have another triangle, and this side is 60 degree. This side is 30 degree now, because you bisect. Then this side is 90. Now, for the abscissa, you have what? Once you bisect, you have 1 here, 1 here. So this side will be 1, and this side is the required side we are going to look for. This one is 2. Now, for you to get this side, what are you going to do? You apply Pythagoras theorem. And Pythagoras theorem states that hypotenuse square equal to opposite square plus adjacent square. Now, hypotenuse here is 2 square equal to the opposite is unknown, right? Plus adjacent. Adjacent is 1. So, for you to get the opposite, opposite squared equals to 2 squared minus 1. Opposite square equals to 2 square is 4. 4 minus 1, you have 3. Opposite is equals to square root of 3. Opposite is equal to square root of 3. So you have square root of 3 here. Now, we've completed the side. Now we have to look for the special angle. Are you getting it? Hope you are getting it. It's clear. Now, the required angle we have to look for are what? Sine 30 degree, cos 30 degree, and tan 30 degree. Also, we have to look for sine 60 degree, cos 60 degree, and tan 60 degree. Now, from here, this is sine 30, right? Now, this side means opposites. The angle facing, the side facing the required angle, that is the required angle you are looking for. The side that faces it will be what? The opposite. That's the meaning. The side facing the required angle is the opposite. Now, since you are looking for sine 30 degree, 30 degree is the what? Required angle. So the side that faces it will be what? Opposite. The side that faces it will be what? Opposite. This one maintain to be an hypotenuse, and this will be our what? Adjacent. Okay? Do you get it? The side facing the required angle, you can note it. The side facing the required angle is the opposite. So, for you to get sine 30 degree, sine 30 degree will be what? Opposite over what? Hypotenuse. Ordinate over hypotenuse is still the same thing. So the opposite here is what? 1, and the hypotenuse is what? 2. So you have 1 over 2. Do you get that? Now, cos 30 degree is what? Adjacent over hypotenuse, or abscissa over hypotenuse. This is the abscissa now. Okay? The angle facing the side facing the required angle is the opposite. So this side is the what? Adjacent. Hypotenuse will still maintain its own. Okay? So this is the what? Adjacent. So adjacent over what? Over hypotenuse, which is 2. So that's root 3 over 2. Root 3 over 2. Now, for tan 30 degree. Okay, someone should tell me the answer for tan 30 degree. What will be 1 over root 3? That is, you multiply sine theta by the reciprocal of what? Cos theta. Okay? That means you are multiplying sine 30 degree by the reciprocal of what? Cos 30 degree, which gives what? 1 over root 3. 1 over root 3. You are getting it right? So, for sine 60 degree, what will be the answer for sine 60 degree? You know that the side facing the required angle is the what? Opposite. So that means this side is now what? Opposite. Now, what will be sine 60 degree? Root 3 over 2. Root 3 over 2. What will be cos 60? 1 over 2. Then tan 60 degree will be what? Root 3 over 1. That is, you multiply sine 60 degree by the reciprocal of cos 60 degree. So that's for tan 60 degree. Do you get it? You all get it right. Now, I want you to note this. The reciprocal of sine theta is cosec theta or cosecant theta, but we don't used to name it fully when talking about it. So you can just say cosec theta. Then 1 over cos theta is sec theta. Then 1 over tan theta, that is the reciprocal of tan theta, will be what? Cos theta over sine theta. You know tan theta itself is sine theta over cos theta. So cot theta is the same thing as what? Cos theta over sine theta. So cotangent theta or cot theta. That's the reciprocal for what? Tan theta. The reciprocal of tan theta is what? Cotangent theta. These are the things you must know. It's very, very important. So you note that, right? Now, from special triangle, we can update a table for it for easy learning. Now, sine, if you are to take sine 0 will give you 0. You see, when we get to quadrants, I'm going to explain that. Sine 0 will give you 0. Now, sine 30 degree from what we did is what? 1 over 2. Sine 45 degrees, 1 over root 2. Yes or yes? Sine 45 degrees, 1 over root 2. Sine 60 degree is root 3 over 2. Then sine 90 degree is 1. Now, if you want to write for cos theta, you can flip it backward. That is, you write from here backward for cos theta. Look at how I'm going to write it. This will be 1. This will be root 3 over 2. Then this one will be 1 over root 2. This one will be 1 over 2, and this is 0. Do you get it? This is what I'm saying. You've gotten this right. Now, you can flip it backward. That is, you write backwards. That will be 1 root 3, 1 over root 2, 1 over 2, 0. Do you get it? Now, for tan theta, 0 divided by 1 will be what? 0. 1 over 2 divided by root 3 over 2. 1 over root 3. Then 1 over root 2 divided by 1 over root 2. This will be 1. Then root 3 over 2 times 2 will be what? That will be root 3. Then 1 divided by 0 will be infinity. Any number divided by 0 is undivine or infinity. Any number divided by 0 is undivine or infinity. So you can compute this. You can compute this also. You just put sec theta, you put cosec theta, you put sec theta, and you put cot theta. So for you to get cosec theta, that is, the reciprocal of this will be what? You see, this thing is just like a game. Now, you said sine 0 degree, sine 0 degree is equal to 0, right? This 0, it means 0 over 1. That's the meaning. 0 divided by 1 is 0. Now, if you want to take the reciprocal of sine 0, you know the reciprocal of sine is what? Cosec theta. Now, if you want to get cosec 0 degree, that will be what? 1 over 0. And which gives you what? Undivine. it will give you undivine. Any number divided by 0 is undivine. Okay? So just put that in mind. You can compute that. Then cosec 30 degree will be what? Just take the reciprocal, you flip it. That's the meaning. Cosec 30 degree will be what? 2. Cosec 30 degree will be 2. Then cosec 45 degree will be root 2. Then this one will be 2 over root 3. Then this one is also 1. Because 1 over 1, if you still take the reciprocal, it's still 1 over 1. Do you get it now? Then for sec theta, you take the reciprocal of all of this one also. Do you get it? Then for this part, cot theta. Cot theta, if you take the reciprocal of this, what will it be? As undivine. Undivine is not the same thing as 0. Undivine is 1 divided by 0. Any number divided by 0, any number at all divided by 0 is undivine. You have to keep that in mind. If you take the reciprocal of this, what will it be? Root 3. Reciprocal of this, 1. Reciprocal of this, 1 over root 3. Because this is root 3 over 1, right? So if you take the reciprocal, it will be 1 over root 3. Now, if you take the reciprocal of infinity, what will you get? Who can tell me? What will you get? This is, it will be 0. How do you get it to be 0? This will be tan 90 degrees equals to infinity over 1, right? So for cot 90 degree, it will be 1 over infinity. How do you get it to be 0? This is a logical proof. That is, you can prove it by using a numerical method. If you take that infinity, 1 divided by 10 is what? 1 divided by 10 is 0.1. 1 divided by 3 is what? 0.333, right? 1 divided by 4 is what? 0.25. 1 divided by 100 is what? Okay, if you say that 1 divided by 1 trillion, it will be 0.00000000000. So as this number is tending to infinity, you know you are getting what? 0 here. So that's how you can use it to explain the logical proof for cot 90 degree. Do you get that? So if you take any number divided by infinity, it will be what? 0. Just keep that in mind. So cot 90 degree is 0. So I hope you all understood. You are not answering because we are getting to real work, and you must get all this. Once you get this, it will be very easy. So we want to start the proof now. Trigonometrical identity. Given a right triangle ABC. Please, I want you all to listen to this, okay? Now, given a right angle triangle ABC, then we can start our proof. We can say from Pythagorean theorem, hypotenuse squared equal to opposite squared plus adjacent squared. Now, hypotenuse here is what? C. That's C square, right? Opposite is what? B. That's what? B square plus what? A square. Now, from here, divide all through by C square. What will you get? C square over C square equal to B square over C square plus A square over C square. Now, this will give you what? 1. 1 equals to B over C all square from the law of indices. Law of indices, you can take it out, plus A over what? C all square. Now, if you remember, B over C will give you what? No, from here, B over C, opposite over hypotenuse. What trig ratio comes to your mind? Sine, Abby. Opposite over hypotenuse. So this gives from here, that's 1 equals to what? Sine theta all square plus, what about this one? A over C. That's adjacent over hypotenuse. That's cos theta all square. Now you can write this to be 1 equal to sine square theta plus cos square theta. So this gives you the fundamental principle also, fundamental theorem of trigonometry. This is the fundamental theorem of trigonometry. So from here, we can derive a lot of proof. Once you know this, you can derive many proofs. So, you all get it right. Now, back to this. If you divide all through by B square, that will be C square over B square equal to B square over B square plus A square over B square. From here, this gives C over B all square equals to 1 plus A over B all square. Now, what trig ratio comes to your mind? C over B. C over B is what? Hypotenuse over opposite. Now, what is sine theta? Opposite over hypotenuse. But this one is giving you what? Hypotenuse over opposite. Now, the reciprocal of sine theta is what? Cosec theta. The reciprocal of sine theta is cosec theta all squared equals to 1 plus what? A over B. What trig ratio is that? So that's what? Now, tan theta is what? Adjacent over opposite over adjacent, Abi? Now from that we have what? Adjacent over opposite. What's the reciprocal of tan theta? Cot theta. So this gives cot theta all square. So this gives cosec square theta equal to 1 plus cot square theta. So that's another proof from fundamental theorem. So you copy that down too. Now, if you divide all through by a square, so this will give c square over a square equal to b square over a square plus a square over a square. So this gives c over a all square equal to b over a all square plus 1. So from here, what comes to your mind? This will be what? Sec theta all square equal to tan theta all square plus 1. So this gives sec square theta equal to tan square theta plus 1. So that's another proof. Don't forget, from fundamental theorem we derive all this. Now let's go to some difference formula. Some difference formula. Now, some difference formula states that if you have sine A plus B, it will give you sine A plus B, that is taking A plus B to be a compound angle. That is, you can have your A to be 60 degree and you can have your B to be what? 30 degree. That's the meaning of compound angle. So if you add them together, you have what? 90 degree. So that means that if you are taking sine 90 degree, okay, let's just continue. Sine A plus B will give you sine A cos B plus sine B cos A. Now, what this is talking about is that if you have sine 60 degree plus 30 degree, it's the same thing as sine 60 degree cos 30 degree plus what? Sine 30 degree cos 60 degree. Now, sine 60 degree is what? Root 3 over 2. Cos 30 degree, root 3 over 2. Right? Plus sine 30 is 1 over 2. Cos 60 is what? 1 over 2. Root 3 times root 3 will give you what? 3. So 3 over what? 4 plus what? 1 over 4. Take the LCM. This will give you 4. So that will be 3 plus 1, which is equals to 4 over 4, which is equals to 1. So that means from the special triangle I gave to you, sine 90 degrees equal to what? 1. So we've proved that sine 60 plus 30 is also equal to 1 from this sum difference formula. If you want to get this very well, you can pick from any of it. So if you are picking 60 plus 45 degree, you are going to get answer 2. Just impute it like that. So I'm just taking this as an example for you to see that is actually correct. So if you want to understand this thing very well, you have to try and prove it on your own using numbers, using the angle actually, because if you are using a plus b, we are just proving through analytical method. But if you want to get it real quick, you can impute some angles for you to see that how it works. Okay, you are done, right? So the second one, I'm not going to prove it, but once you impute it, you are going to get an answer, and it must be equal sine a minus b. Sine a minus b is equal to sine a cos b minus sine b cos a. So if you want to prove it, you can pick your a to be 90 degree, and then your b to be 60 degree. So 90 minus 60, you have what? 80 degree. So that means this side is sine 30 degree. Then you impute everything here, you are going to get the same answer for both sides. So cos a plus b is equal to cos a cos b minus sine b cos a. The same thing for this 60 30, taking them as a compound angle is the same thing as 90 degree. So cos a minus b is equal to cos a cos b plus sine a, this side should be sine a sine b. Okay, change it to this should be sine a sine b. Then this one cos a cos b plus sine a sine b. So you put that down. Now let's do for tan a plus b. Tan a plus b is the same thing as sine a plus b over cos a plus b. Now, what's sine a plus b from the one we've written? Sine a cos b plus what? Sine b cos a, right? Then cos a plus b will give you what? Cos a cos b minus sine a sine b. Now from here you can't leave it like this, so we are going to proceed. Divide all through by cos A cos B. So tan A plus B will now be equal to sine A cos B over cos A cos B plus sine B cos A over cos A cos B, all divided by cos A cos B over cos A cos B minus sine A sine B over cos A cos B. That is, you divide through by cos A cos B. We want to derive something. We want to make it smaller rather than making it so big like this. Now, if you look at this closely, you see that cos B, we cancel cos B here. Cos A, we cancel cos A here. Then this one, you are left with what? 1, right? This one, we divide each other to give 1. Then this side, this will be tan A, Abi. This side now is tan A, and this one is also tan B. So that's tan A, tan B. That is, they are multiplying each other. Tan A times tan B is the same thing as tan A, tan B. Okay? So we can rewrite that to be equal to now cos B have cancelled each other. So you are left with what? Sine A over cos A. Sine A over cos A is what? Tan A. Is what? Tan A. So this will be tan A plus tan B over 1 minus tan A tan B. Okay? So that's what it's going to give you. Can you see that everything has become smaller rather than leaving it like this? Although if you put your angle, that is the compound angle A plus B, if you put it there, you are going to get the same answer with this. So it's not clear which side. This place, Abi. I said divide all through by cos A cos B. That is, every single element in this, you are going to divide it by cos A cos B, both the numerator and the denominator. Okay? So this side you divide by cos A cos B, and this side from here, do you get? You divide this one by cos A cos B, divide this one by cos A cos B, divide this one by cos A cos B, and this one also. So you notice that cos B, they are the same. They cancel each other to give you 1. 1 times sine A over cos A is what? Tan A. That's why I got tan A here. Cos A, we cancel each other. You are left with what? Sine B over cos B, which gives you what? Then this one, they all cancel each other to give you what? To give you 1. So then for this side, sine A over cos A is tan A, sine B over cos B is tan B. Note that we might not be able to finish this today. Okay, so by next class we are going to be solving questions, but for today we are only going to get the trigonometric identities. So when you get home, you can walk through it. Then you bring your question. If you don't understand, you bring it here, then we solve together. So by next class, we are going to be solving questions. Okay? So you get prepared. I'm going to give the trigonometric formulas you are going to need. So once you get home, you can walk through it and solve questions. Then you bring it here. We can solve together if you don't understand. Then we move to next thing. So are you done with this? Now, I'm not going to prove for tan A minus B. It's still the same thing we are going to do. So, if you have tan A minus B, if you have tan A minus B, it's the same thing as tan A plus tan B over 1 minus, tan A minus B over 1 plus tan A tan B. So that's for tan A minus B. That's for tan A minus tan A minus B. So from there we move to double angle identities. Double angle identities. Is there any other department here? Which department? Computer science. Okay, you need it too. You need it. Now, what I'm going to say is that for mathematics students, you are going to need this proof and you must know it. Must know it offhand and you must be able to prove it. But for other departments that will not do mathematics for longer time, you may know it, just know what it equals to. Like this one now, it has a proof. But for other departments, maybe biology, you can just know it directly here. But for mathematics, you must prove it. You must be able to prove it. So let's move to double angle identity. Double angle identity. Theorem 1, sine 2a is equals to 2 sine a cos a. Now, this is what we want to prove, that sine 2a is equals to 2 sine a cos a. Now, we prove from sine a plus b equal to sine a cos b plus sine b cos a. We can derive this to be sine a plus a, right? Because a plus a is what? 2a. So sine a plus a is equals to sine a, that is, you are following this now. Sine a cos what? A plus sine a cos a. So this gives you what? Now, the coefficient here is 1 and this one is also 1. Take this one as a single function. Maybe you can represent it with x. It's not clear. Sine a cos b plus sine b cos a. Okay, for this side, Abby, I'm saying that this sine 2a is the same thing as what? A plus A, which is sine 2A. Now, if you follow this step here, sine A cos, since this A is representing B here, so that will be cos A. Do you get it? So, if you take this as a single value function, maybe you represent it with x. This is x, this is x. X plus x will give you what? 2x. So this will give you 2 sine A cos A. So it means that sine 2A is equal to 2 sine A cos A. 2 cos 2A is equal to cos square A minus sine square A. Cos square A minus, cos square A minus sine square A is equal to cos 2A. Now, we can prove this from cos A plus B is equals to what? Cos A cos B minus sine A sine B. Now, cos 2A is the same thing as A plus A. You see, the beauty of this thing is that when you represent it with what? Numbers, that is angles, you can take your A to be what? 30 degree. You can just say that 30 degree plus 30 degree. Then you input it, then you get your answer. So this will give you cos A cos what? A minus sine A sine A. Now, if you take this one as x, this one is also x. X times x will give you what? X square. So this will give you cos square A. If you take this one as y, you take this one as y. Y times y is what? So this will give you sine square A to be equals to cos 2A. So that's how it's proved. Also, from there, you can say that cos 2A is equals to 1 minus sine square A minus sine square A. That is, this cos square A is equals to what? 1 minus sine square A. How do I get that? We've proved it from fundamental theorem that sine square theta plus cos square theta is equal to what? 1. So if you make cos square theta from that fundamental theorem, you make cos square theta to be the subject. So it means that sine square theta will go to other side, becoming what? Negative sine square theta. So it's the same thing as this. So you can also say that cos 2A is the same thing as 1 minus 2 sine square A. So you are going to put it under it also. Also, you can generate your cos 2A to be equal to cos square A minus open bracket 1 minus cos square A. Because of this negative, I'm going to put brackets. Because this negative belongs to what? Sine square A. Okay? And I told you that sine square A is equal to what? 1 minus cos square A. Right? From fundamental theorem of trigonometry. Okay? You make your what? Sine square A to be the subject of formula. So this will give you cos square A plus 1, minus 1 plus cos square A. So this will give you 2 cos square A minus 1. So cos 2A is also equal to this. When you get to prove that sine square something is equal to something, that's when you are going to need all these identities. At least you must know up to 70% of it for you to be able to answer those questions. Let's go to theorem 3. Theorem 3 under double angle identity. Theorem 3. Theorem 3. Theorem 3 states that tan 2A is equals to 2 tan A over 1 minus tan square A. Now, can someone prove this? This is, you can state the proof from tan A plus B to be equal to what? Tan A plus tan B over 1 minus tan A tan B. Now, you can represent this 2A to be equal to tan A plus A, right? Equal to tan A plus tan A over 1 minus tan A tan A. So this definitely give you what? Tan A plus tan A will give you what? 2 tan A over 1 minus tan square A. So is proved that tan 2A is equals to 2 tan A over 1 minus tan square A. Hope you are all getting this. You must get it. It's a must. It's a must. You must get it. And if you don't understand, you can just signify. I will explain. Okay? So we are done with double angle identities. Now we move to half angle identity. This is double angle identity. Now we move to half angle identities. Half angle identities. Now, let's prove this. From cos 2A is equal to 1 minus 2 sine square A. I believe we've proved this, right? We've proved it from double angle identity, right? That's what we are going to be using to prove another identity. Now, cos 2A is equal to 1 minus 2 sine square A. If you make sine square A to be the subject of formula, what will you get? Sine square A will now be equal to cos 2a minus, so that will be 1 minus cos 2a. Do you get it? No. If you take this to this side, it will be minus, right? But this one, we have a minus here. You use that minus to open this one. Or you divide through by minus. If you divide any number by minus, okay, sorry, this 2 here supposed to be 1 over 2 into brackets cos, sorry, to brackets 1 minus cos 2a. So this is it. Now we want to arrive at this point. Note this. If you have sine square n theta is equals to 1 over 2 1 minus cos n2 theta, where n is a member of natural number. Look up, or let me just say real number. Real number will be okay. This is what I'm saying. That is, any number you multiply by the angle, that is, the number belongs to what? Real number, set of real number system. If you pick any number from real number system and you multiply it by the angle theta, you are going to get 1 over 2 into brackets 1 minus cos n2 theta. Okay, you note it under this. So we can continue with that. Now, if I take my n from here, you know, n here will be what? N here will be what? Who can tell me? 1 over 2. Because this is the angle, right? A is the angle. But it is being multiplied by what? 1 over